Hello everybody, my name is Jacob Madrid and today we're going to be diving into relative dating. So why use relative dating? So we use relative dating to explain age dates if we don't know the exact age or absolute age of it. So this will work perfectly for sedimentary rocks that may not have the minerals that can help us absolutely age this rock. Like for example, there may be a rock and we could use carbon dating, uranium dating, or zircon dating. But for these types of rocks, that may not be much of an option here. So because of that, we have to follow a few principles. For example, the principle of horizontality, which states that everything wants to be layered horizontal when it is fully layered. So that's why we see all of these flat parallel beds from A through D. Next, we would have the principle of superposition. So the principle of superposition states that whatever's in the bottom is the oldest and whatever's on top is the youngest. So for example, we'll have rock layer A, B, and C, and D. So A would be the oldest since it is at the very bottom, and D would be the youngest since it's at the very top. There's another principle that we'll be using today, and that would be the principle of cross-cutting. So whatever the intrusion, like for example rock E, cuts through will be younger than the rock layers that it cuts through. So to make it more clearly would be that E would be younger than both A, B, and C since it cuts through them. So if you want to do the age of all of these rocks, A would be the oldest, B will be the second oldest, C would be the third oldest, E would be the second youngest because it cuts through A, B, and C, and then D would be the youngest out of all these rocks right here. So since we're starting to learn that, we'll then go into the map view. So we have this little cross section or this little map view of what's all going on, or just an example of how things can change. So in the map view, we have this sandpaper. I could feel it, and I could feel how coarse it is and how it makes a very distinct sound when I run my fingers through it, my nails through it. So as we can see from the map view is just simply whatever we see directly on the map. So directly down below, so if you're going a hiking trail, your map view would just be look down, and that would be your map view. So it doesn't give us what's going on down below this, because there could be quite a few things where we could say all it is just this specific rock all the way through. However, that is not the case for this example. If we look on the legend, we have this sandpaper, which would be my sandstone. We have these rhinestones, as will be my dike. And you could feel it, and you kind of feel like these ripples or these bumps that go through it. And then I have these green schists, which will be this green felt that feels soft and feels smooth. It doesn't really make much of a sound when I scratch it. I then have this burnlap that makes this very distinct scratching sound when I go through it. And it feels semi-smooth. And then last, we'll have the quartzite. So the quartzite is just this rope, and has this very distinct and unique feeling as you run your hands through it. So next we'll go into our cross section. So at the very bottom right, we have the quartzite with the ropey material. And then in the middle, we have the burnlap. And we could feel it and scratch and feel it around to make sure that we know that it is. And then on the very left, we have the green schist. And then at the very top, we have the sandstone. So using the laws or the principles that we learned a little bit earlier, we're gonna help try to distinguish between what is the oldest and what is the youngest. So we know that all these were once horizontal, but now due to folding, they're tilted now at a slight angle. So whatever angle is the shortest to the ground, so we see it's at approximately a 45-degree angle, so we want it to go all the way flat. So because of that, we'll see that the quartzite will be the youngest out of all of them. Next, we have this burnlap that's right on top of the quartzite. And then after that, we see that we have this intrusion. We have this little dike that cuts through both the quartzite and the Burnlap. So because it cuts through that, due to the principle of cross-cutting, the quartzite and the limestone will be older than this dike right here. And then the dike will be then older than the green schist. And then we have the sandstone at the very top. So due to this, we can say that the sandstone is the youngest out of all of this. So overall, I hope this helped me explain relative dating. Thank you.